good day, sir. My name is Lias Picture from BS Marine 3rd Year Delta, and I am going to discuss and describe the 4 types of indicator diagram. And our members are these: John Roland Calope, Alvin Dumangas, Kyle Vincent Noya, and Georgian Asido. Indicator diagram. So first is that the indicator diagram is very important to know the combustion in the cylinder and also to adjust the engine. So for me, the explanation of that is that the diagram is taken periodically. Why? Because from the indicator valve, it is equipped on the cylinder head, and also the combustion condition is to be confirmed. Then second, the diagram is taken periodically from the indicator valve equipped on the cylinder head, and combustion condition is to be confirmed. So the third, the compression pressure and the maximum pressure in the cylinder can be presumed from the indicator diagram. So based on my explanation, is my knowledge is that the engine indicator is that we use the device to take the indicator diagram, which can be considered as a stethoscope, yes, for diesel engine. So the fourth is that engine indicator is the device used to take the indicator diagram, which can be considered as a stethoscope for diesel engine. So for me, indicator diagrams gives efficiency. Why? Because the combustion in the cylinder, it has a condition of the running gear, irregularities of in fuel, in especially pumping and injection, and a lot of things. So lastly is that the indicator diagrams give efficiency of the combustion in the cylinder, condition of the running gear, irregularities in fuel, pumping and injection, and a lot of things. Use of indicator diagram. So the indicator diagram is used to calculate the work done and the power produced in an engine cylinder or used in a compressor cylinder. So it is used to measure the thermal or cylinder performance of reciprocating steam and internal combustions. So we focus on the internal combustion engines. So in an indicator chart records the pressure in the cylinder versus the volume swept by the piston. So throughout the 2 or 4 strokes of the piston, which is constitute the engine or compressor cycle. Question is, why is it important to know the indicator diagram? So for me, the indicator diagram is very important to know because the combustion in the cylinder and also to adjust the engine. So therefore, the diagram is taken periodically from the indicator valve, which is equipped on the cylinder head. And also, the combustion condition is to be confirmed. So we used to assess the performance also of each unit of the ship's main engine. So it is basically on the indicator diagram that the overall performance of the engine is assessed. There are 4 types of indicator diagrams that can be taken from the engine cylinder to know the condition and performance of the engine. And these are power card, draw card, compression diagram, light spring diagram. The area of indicator diagram is calculated by the planimeter usually used on board. Mid-ordinate method. So in these 4 types, they're the one to report on what is the function of the draw card, power card, compression diagram, and light spring diagram.
So next is the power card. So what is a power card? So a power card are used to indicate the power developed in a particular unit. So it is a PV diagram. P is in the y-axis and the V is in the x-axis. So P is the pressure which would raise through the stroke of the cylinder during combustion cycle, and the V is the change in volume. So first is we need to draw an atmospheric line which indicates the atmospheric pressure. So the atmospheric line needs to be drawn with the instrument connected to unit, so that we can give exactly the length of the power card. And then after that, you have to see or look the indicator cock so that we can ensure that there is no carbon deposits there. So after that, we need to screw the indicator instrument into the indicator cock and then attach the boulder cog out and then attach it to the pulley mechanism to the indicator, which turns the indicator can on the engine. So once you do that, the drum automatically starts to rotate, and then you will get a power card of something like this one. So the curve line is the compression curve, and the other side is the expansion curve. So due to the combustion of fuel and gas, and the actual combustion happens at the highest point and the lowest point where exhaustion process happens. So to calculate the amount power developed by the unit, the formula is in here is power is equal to area in the expansion curve minus the area under the compression curve, in order to get the indicator power within the cylinder.
Compression diagram is taken in similar manner to the power card, but the fuel is shut off in the cylinder, so it is cut off. So the compression card or the compression diagram, in this diagram, the purpose of this compression diagram is for us to check the alignment of the indicator cam, which is the with the indicator cup. This means that this compression card is telling us the indicator is aligning, or it is in the alignment the drum rotation with the main engine piston. So in this compression diagram, this process is taken with a fuel cut off, meaning there is no fuel or there is no power stroke. So in the diagram, you can observe that it has only one alignment or one line, which has an arrow of going up and going down. The going up arrow is from BDC to TDC, and the arrow that is moving towards the volume or moving down is from TDC to DDC. In this diagram, it should have two lines, but because of the fuel cutoff or the no presence of fuel, we can only have one alignment or one line. So in this diagram, there is a relationship of pressure and volume. We'll have an indication as the pressure decreases, the volume increases. Because there is no enough great pressure, the volume keeps on increasing. So we can conclude that as the pressure decreases, the volume increases. The relationship between pressure and volume are inversely proportional.
So I will discuss the draw card diagram or outphase diagram. So draw card is taken in a similar manner to power card with a fuel pump engaged with the indicator drum. It's about 90-degree out of phase with a piston stroke. And then this diagram illustrates more clearly the pressure changes during fuel combustion fuel. Timings or injector faults may be detected from its shape. So the draw card diagram is taken with the same indicator instrument with its drum 90 degrees out of phase with a piston movement, and it gives us a better understanding of pressure variation within the cylinder. Thus, it helps us to differentiate between the compression pressure and peak pressure for the particular cylinder. Then, by the use of draw card diagram, we get a clear indication of the faults in exhaust. So, injection and exhaust systems, even effects for improper settings of the indicator instruments, are much clearer in the diagram. So this area of the diagram gives us the main indicate pressure or total power produced for the system. And then the draw card diagram is the pressure rise as the piston starts to move up. Now the maximum pressure to which air pressure reaches before the start for the combustion process or during combustion process, and it's called compression pressure. And then this can be seen in the form of small bulge in the diagram. So a combustion starts and pressure rise again and then falls gradually as the expansion and exhaust stroke starts to happen.
To the power card and in phase with the engine and with a light compression spring fitted to the indicator. So this diagram shows a pressure change during the exhaust and scavenge to an enlarged scale. It can be used to detect fault in this operation. So a light spring diagram is taken when there is suspected irregularity in the exhaust and inlet stroke. It scales and enlarges the deviation in pressure enough to be visible. So the pressure change during scavenging and exhaust can be monitored and required change are being done.